and welcome everyone to this first webinar in our series. I will first share a bit about the project. Equality is a huge consortium of 8 partners, from small to large companies, startups, research institutions, academia, all joined together with a single huge goal to develop something useful for industry, quantum applications, quantum algorithms, and middleware, such that it would make the developing quantum computers applicable to the relevant problems. The project started at the end of 2022, and now we are approaching the conclusion of this 3-year project funded by European Union. It's actually one of the largest single grants awarded by the European Commission, and therefore we would like to share in these webinars some of the most interesting results of the project. We will start with the goal. So the aim of it all was to pinpoint the most potential use cases for the nascent quantum computers and develop something that would make them relevant by the time the technology matures. We have identified the 3 large domains of applications. These are aerospace and energy. Specifically, we have 3 core paradigms. So first is solving differential equations, helping at aerodynamics and electrochemistry, for example. The second one would be developing all sorts of novel optimizers to help people tackle the scarce resources more efficiently, such as, for example, for the space mission planning. And as well, our partners develop novel approaches to image processing, such as with quantum machine learning. And finally, we simulate the chemistry of batteries and fuel cells better with classical and quantum computers together, comparing them and figuring out what would be the best next step. Equality project sets very ambitious goals ahead of it, and it would not be reachable if we don't squeeze the best out of quantum hardware at any point of its existence. For that, we aim to develop not just a bunch of algorithms dedicated to use cases or to the fundamental problems, but rather a full stack approach. That means that we try to make the best out of hardware with different hardware utilization routines the partners develop for different type of quantum computers, because it's still not evident which quantum computers would mature first and which would be better for different problems. As well, we develop more transversal middleware algorithms, such as efficient hardware utilization or circuit tailoring that would benefit for all sorts of use cases. And finally, the partners develop the core algorithms, again, such as differential equation solvers or chemistry simulators, that will be beneficial across industries. And finally, we couple it all in a full end-to-end pipeline. The goal of this project is to develop the demonstrators, the core technologies. And today, our partners would present a few of them. This webinar will focus more on the core algorithms that would be partially transversal to different use cases. And the next 2 webinars would focus more on the use case specification.